I've added a clock and a program counter to the breadboard computer, and it now counts through the addresses on the address bus, which is cool. So the clock is a 555 timer just here in astable mode, and the output of the clock is still flashy lights here. I've also inverted that to give me a sort of anti-clock here, and the idea being is I may want to trigger something on the rising edge of the clock and then trigger something else when the clock falls off back down to zero, and you can do that with an inverted clock. Whether or not I'm going to do that or not, I don't know at this stage, but it's there in case I do. There's a second 555 here, which is in monostable mode, which means if I turn the clock off automatic onto monostable, I can press the button and it does a single pulse of the clock. The reason for using a 555 in monostable mode to send a single pulse instead of just sort of decoupling with a little capacitor like I have on the right button for the memory is to do with multiple pulses. On the memory, even if I do get a multiple pulse with this basic decoupling, it's not going to make any difference to the write signal. The memory will still write, but with the clock, if you get a double pulse when you press the button and it's not decoupled properly, that will cause two clock pulses, and you may find that your program or your circuit goes further than you expected it to on a single pulse. Put that back on. Both these clocks signals are fed through AND gates in conjunction with the switch, and I'll put the diagram over here somewhere so you can see it, the logic diagram, and that just means it's either that signal is being passed through or this signal is being passed through, depending on the position of that switch. Both of those are then fed through an OR gate, which means that if one or other of them is active, then you get a clock pulse going to the rest of the circuit. I've also inverted the signal, and that's what's producing the anti-clock. We then have a couple of 74HC 193s, I think, which are 4-bit counters. They're not just counters, they also have a parallel load function, which is why I selected those chips. And the reason for that is because if you're running a program and you perform a jump function or something like that, you need to change the value in the program counter. The only sensible way of doing that is with a parallel load. The two chips are connected such that if the lower significant bit chip goes over 16, so 1111, it then clocks the most significant bit counter accordingly. The clock is fed into the count up function, and as you can see from the little LEDs on the address bus, that seems to work okay. There's also a clock down function. I can't think of a reason why you'd want to use that in program. No, I can't. However, if you're debugging a program and you might want to step back a couple of steps, I can kind of see that being reasonably useful. So I have included a little button here, which in theory at least will step back one clock signal. There's also we spoke about the parallel load, and I've set up a temporary set of dip switches here, which will, in theory at least, load the value held on these dip switches into the preset load. And the second button along here is the one that sort of triggers that, and the final button is just a reset, which resets the counter back down to 0, 0. Now, unfortunately, none of those buttons actually work the way I expect them to work at the moment. And so if I press the reset button, it does indeed reset it to all to 0, but it doesn't start the clock again. Maybe I'm not understanding how these counters work, but I would have thought it would have done. And if I press the program load button, it kind of does weird stuff. It does start counting again, as you can see, but it starts from 1, not from 0. So I'm missing something, but I've got to work that one out. The only other changes I've made is I've realised that the program counter owns the address bus, and the only place that the address bus goes from the program counter is to the address connections for the memory. It doesn't go anywhere else, so I've removed the connector along here, which I was going to use for additional connections to the address bus. And of course I've moved the dip switches for setting the address bus manually and put those switches there instead. You may also notice that on the right hand side I've set up started to set up a display, and this is what I'm sort of experimenting with at the moment. The two 7-segment displays are common anode, and whether or not they get power is dependent on these two little NPN transistors here, which at the moment are being switched on and off by the clock and the anti-clock, just to demonstrate the switching between the two displays. All the segments that are the same are paired and fed to the same part on this pack of resistors, and then the other side of the resistor pack is then fed to either VCC or ground. If I want the LED illuminated, it goes to ground, and if I want the LED off, it goes to VCC. Now the idea here, as you can probably guess, is to multiplex the display, and the way I'm going to do that ultimately is through a EEPROM. So I should, and the reason for using the EEPROM rather than using a standard sort of decoder chip is that the hex decoder chips that I want to use are quite expensive, and I'll be honest with you, it's cheaper to use an EEPROM. So between the EEPROM, which will go about here, and the resistor pack, there'll be some sort of a buffer chip, probably another 244, and that's just because I don't want to connect the outputs of the EEPROM directly to the LEDs. I'm sure it would be fine, but you know, you've got to protect your capital ships, haven't you? And then on the input of the EEPROM, there'll be two latches. I haven't decided what latches they are going to be yet. What they're going to do is they're going to split the 8-bit data bus into two 4-bit nibbles, which then each drive one or the value that appears on one or other of these 7-segment displays. My only concern really at the moment is whether or not I'm going to fit all this along this bit of board, because I'd like to keep it sort of modular if I can. At the top of the board there's another little 555 clock. At the moment that's running at quite a low frequency because I'm just playing with it, but I will eventually use that at a much higher frequency, somewhere between 50 and 100 Hertz, and that will maintain the illusion that the two displays down here are illuminated at the same time. So the next video will probably be tidying up the cables over here on the program counter because they're a mess, and further progress on the display side of things.